Welcome to Physics, Alternating Current, Session 5. Today aim of our topic is to study parallel LCR circuit. Also we will study about choke coil, parallel resistance, inductance and capacitor circuit connected across an AC main. So here we have a resistor, here we have inductor, capacitor. When connected to a AC mains, V is equal to V naught sin omega t. Current I starts from here. Across the resistance, current I will be becoming as IR, across inductor IL, across capacitor IC. Consider parallel LCR circuit. The potential will be across resistor, inductor and capacitor same. So, in the phasor diagram, keeping the potential same, let us see whether current is in phase or current is lagging behind or current is ahead. If we consider resistor by the phasor diagram, we know in case of resistor, the potential across the resistor and the current both are in phase. This is across the resistor. Across inductor, the potential is ahead of the current. So current will be in this direction. IL is the inductor current, potential is V, and current is lagging behind voltage by a phase of pi by 2. And across capacitor, if we take the potential as V here, across capacitor the potential is lagging behind the current IC. So current is ahead of the voltage by a phase of pi by 2. So the current IR we can consider as V naught by R, current IL across inductor, it is V naught by XL, XL is the inductive reactance. Across capacitor IC is equal to V naught by XC, XC is capacitive reactance. So if we merge all the three together, we can get keeping the potential in the same phase. Let us say this is V. Then the current in the resistor will be in the same direction. This is IR. IL we can mark it in this direction. This is IL and IC upward. This is IC. So first take the difference between current in capacitor, current in inductor. Say if the resultant current is in this direction as IC minus IL. IR in another phase, taking this as the resultant, we can calculate the total current like this. This is I. So what will be I equal to? Under root of IR square plus the difference of IC and IL. IC difference IL whole square or IC minus IL whole square. The angle this current makes with the voltage now is phi. Then we can also write tan phi will be equal to IC minus IL, that is in this direction, divided by IR. Earlier when series circuit we have taken, since current was same, we have taken current in one direction and drawn the phasor diagram for the voltage. In parallel circuit, keep the voltage in this direction for all the resistor, inductor, capacitor. Now we have drawn the current. Current in the resistor is in phase. Inductor it is lagging behind by a phase of pi by 2. In capacitor it is ahead of phase of pi by 2. Merging all together, we have calculated the resultant current. So current and phase difference we got it now. This is IR, this is IC, this is IL, this is I. This value will be here IC minus IL. This is phase I. So we simply got it. Current I is equal to under root of IR square plus IC minus IL whole square and tan phi, which will give us the phase as IC minus IL divided by IR. So phase angle phi will be tan inverse of this. Admittance Y of the circuit. To calculate admittance, we know current I can be written as V naught by Z. So this V naught by Z will be under root of IR square, that is V naught by R whole square, plus IC minus IL, that is V naught by XC minus V naught by XL whole square. So V naught we can take it out and cancel. 1 by Z, that's equal to under root of 1 by R whole square plus XC is 1 by omega C. So omega C difference 1 by omega L whole square. 1 by Z is called Y and Y is called admittance. Reciprocal of impedance is called admittance. Unit will be ohm inverse. And admittance is under root of 1 by R whole square plus omega L difference 1 by omega C whole square. So once we know the value of admittance, we can also calculate the current as 1 by Z. So it is V into Y. This will be the current. So finally, the current will be I is equal to V into Y or V by Z, that is equal to V under root of 1 by R whole square plus omega C difference 1 by omega L whole square. And the phase phi will be tan inverse IC minus IL, that is omega C difference 1 by omega L divided by 1 by R. So we can calculate the phase from here. So as the angular frequency omega value increases, the minimum value of current will be this factor when it becomes 0, V under root of 1 by R whole square, that is V by R. So V by R will be the minimum current at this point. From here, as omega C increases or decreases and 1 by omega L increases, this factor, so omega C minus omega L will be negative. So again it will start increasing. So minimum value of current will be at omega naught. So at omega is equal to 0, I tends to infinity. The current through the circuit will be maximum. When omega is equal to omega naught, the current will be minimum, and that will be equal to V by R from this relation. When omega is equal to infinity, the current again tends to infinity. The graph will be as shown. So minimum current will be at the resonant frequency or omega is equal to omega naught. When DC voltage, if you take it, the angular frequency is 0. So the current will be maximum. And thereafter current decreases, and at omega is equal to omega naught, current becomes minimum, and thereafter current again increases to maximum. Power, if you want to calculate the value of power is P is equal to V square by Z. So it can be written as V square into 1 by Z. 1 by Z can be written as under root of 1 by R whole square plus we have omega C minus 1 by omega L whole square. So from here we can get it. At omega is equal to 0 for a DC voltage, power will be infinity. Similarly, when omega is equal to omega naught, the power will be minimum, and that will be equal to V square by R. Again, when omega tends to infinity, the power also will become infinity. The graph will be as shown, similar to that of the current, but its V square by R is the minimum value at omega naught. And thereafter, as the frequency increases, the value of power also increases. Resonance. At resonance, the current across the inductor and across the capacitor becomes same. And that is, when IL is equal to IC, the current becomes minimum. And that should be equal to current across the resistor, IR. And phase angle phi becomes equal to 0. So IC is equal to IL, I minimum is IR when phase angle is equal to 0. So we get it when IC is equal to IR, the value will be omega C will be equal to 1 by omega L, or omega will be equal to under root of 1 by LC. And this frequency we call it as called omega naught. When the current is minimum, the frequency we call it as called omega naught. Angular frequency is omega naught. This is called resonant frequency. So nu, if you want to calculate resonant frequency nu is equal to 1 by 2 pi under root of LC. Here phi is equal to 0. So power factor will be maximum. Power factor, that is cos phi. It is equal to 1. It is equal to maximum at the minimum current which we considered. The impedance here will be maximum, admittance will be minimum. Z maximum will be V by IR, that is equal to R, the resistance part we can call. So at omega is equal to omega naught, the current will be equal to V by R.